So the other day, yesterday, day before that, we've been talking about ethics of statistics and how we should be intelligent observers of graphs, articles, documents that are presented, trying to maybe persuade us one way or the other. Okay. I just found a series of graphs here. This one was from when George W. Bush was president, okay? And it shows how we can take data and completely mislead our audience in the way that we display it, okay? So I know the cut and paste here wasn't great, so there's some percentages here. I was talking about a tax cut that was about to expire. And I was talking about percentages. So tax cuts, it was talking about the idea of, if it was going to expire, that means the taxes were going to be raised at that point. Does that make sense? And it was kind of trying to talk about the differences of where they were now and where they're going to be. And right now, this says 35%. And if we look over here, my y-axis is 34%. It goes to 36%. Goes to 38%, and it goes to 40%. Okay? This right here says 39.6%. Okay? Now, my hope is that you see that we're not lying with the data. I mean, we didn't skew the data or anything like that, but would you agree that the way that we present this by zooming in on 34 to 36 to 38 to 40 and plotting where 39.6 is and 35.0 is, this is accurate information, but that visual kind of makes you think, oh my gosh, this tax cut's gonna kill people, right? It's gonna hurt workers. Does that make sense? Where if we actually put them from 0% up to, if 100% here, so we keep it kind of zoomed out, and the way we think about percentages, is it really that big of a difference? Does that make sense, everybody? Okay, so somebody that was trying to maybe motivate voters because of this tax cut expiring and then that they weren't going to extend it or anything like that, would probably maybe present the graphic to their audience with the left graph. And somebody that was trying to say, yeah, the tax cut's going to expire, and we're not going to extend it, but this is the difference, would maybe send this to their audience. Does that make sense, everybody? Okay. Let's look at this one. Okay. So this one's talking about sales by year. So let's say that I'm a CEO and I've got a person that's working for me, in charge of a department of sales or whatever, and I need a reason to present to the board that we want to fire this person. Okay? So I give this data right here. Okay? I give in 2015, 2016, 2017, 2018, this was their yearly sales. Okay? And I show that, obviously they're doing okay in 2018, they've done okay in 2016, but there's a drop in 2017. Okay? And it looks, if you look at that, the sales in 2017 were very, very small in comparison to the other sales, right? But look at the y-axis. How many units are between that interval compared to the units in that interval? There's 200,000 units in between that interval right there, right? How many are here? Just 50. So does that allow us to skew this and make this look a lot different than what it should? If we kept the scale on the y-axis the same, there's a more accurate representation of what's going on. And now maybe you can say there was a dip, but was it really enough for me to have cause or reason to fire somebody? Does that make sense? Okay. So I think you need to be able to analyze graphs, and I think we're capable of this. But a lot of people, a lot of that are, whether you're a consumer or you're a voter or something like that, we take for what is written inside newspapers, magazines, TV commercials. We take it for granted for what, I mean, we believe that everybody that is writing those things, publishing those things, is honest and doesn't have a self-interest or a narrative that they're trying to push. Okay. Here it's sales by month from July to December. It is the exact same data. Okay. This point right here is like, it's January, comma, 375. Is this January, comma, 375? Okay, we've got, I guess it's July to December, so that's July, sorry. We got August, okay, and it's at 400. Is this still August, 400? We can go through each one of those pieces of data, okay, but does the left one, does that image compared to the right one, okay, does it look like there's a less growth than what the right one shows? The right one shows a great steeper growth from like October on, right? Does that make sense to everybody? Okay, but it's the exact same information. But if I want to argue to somebody that the between October and December I had great growth, maybe I construct my graph, my y-axis, in a different manner to make it look like it's more vertical, like we've got that that greater increase here. Okay, and you can see all they did was they took their y-axis and they broke it because they don't have data that is less than like 350. So they basically took this information here, that part of the graph, and that's what that is right there. Right? You guys have seen that in science where we break a graph and bring the y-axis down, right? Okay, and it gives a different than visual of what our data is actually saying. Does that make sense to everybody? So those are always things that we want to be aware of, we want to think of when we are reading graphs, but also at the same time when we are constructing graphs. Okay, so my hope is that like the things that I teach you in class, like I lead you to being like morally grounded and ethical. So like I'm going to try to teach you not to do those types of things. If you ever find yourself in a situation where maybe you are leading a company or you're presenting statistical data, that you are honest with it, right? And honest the way that you present it. We're going to start creating different types of graphs over the next couple of days. Okay, so when we start talking about these different graphs, there's rules, procedures that we have to go by so that we construct these graphs correctly. Okay, there's just kind of like general, overall accepted techniques and procedures. So try to teach you those for each one. They're not hard. A lot of them you've already seen. First one, very simple line graph. And there are variations of line graphs. So we'll talk about a time series graph in the next couple of days, which is a type of line graph. Okay. We'll talk about ogives, which is a type of line graph. But it's a type of chart that used to show information that changes over time. Okay. Doesn't always have to be time, and even the example that we're going to see here in a moment does not talk about time. It says we plot a line using several points connected with straight lines. Okay, we also call it a line chart or line graph. So the line graph comprises of two axes, x-axis, y-axis. Okay. The one thing to remember is that your y-axis, and this is the number one issue that I have with students trying to develop the different varying graphs, is if I have two columns of data. Okay, here we have a column of data, number of times that we put our car in the shop versus the frequency. So we've got two lists of data, and I'm not sure, people get confused. Well, which one do I let be the x-axis? Which one do I let be the y-axis? Okay, if you can remember which one's supposed to be which, okay, I just remember one, and it automatically defaults to the other one. So with a line graph, your y-axis is always your frequency. Okay, your y-axis is always your frequency. So that means our x-axis is going to be then, in this case, the number of times we take our car to the shop. Okay. It says 40 people in the survey were asked how many times per year that they had their car in the shop for repairs, and the results are shown. Construct a line graph to display the data. Okay. Now, when we construct the data, I'm going to look at my frequency, and my lowest frequency is 7, right? Okay. When I create my chart over here, I'm not going to, and actually I'm going to cut and paste this so I don't have to keep going back and forth. Because we don't have any data below 7, I'm not going to write on my y-axis like 1, 2, 3, okay? Because it's going to be barren down here. It's not going to be anything to graph. So what I'm going to do is break my graph. Okay, so we're going to put that little symbol there. Over there we go. Break my graph. Sometimes you see that break as being drawn, like they'll do this and they'll just put 2 like slashes through there. Okay. So a couple different notations, but they all mean that they've compressed. This here is a lot of your y-axis just compressed down. Does that make sense? Or cut out and removed. And I'm going to start at 7, and we'll go up to 8, 9, 10, 11, 12, 13, 14, and then 15. Yes? I can't now. Sorry, it's not. Don't worry about the lines here. Is that what you're talking about? Next thing I'm going to do is I'm going to put the number of times in the shop. So on my x-axis, 0 times, 1 time, 2 times, 3. The one thing to think about that can make our data representation look skewed, and we want to avoid this, is if we keep our intervals the same. That will keep our data being more truthful. Okay. If I were to squeeze down, the distance between 1 and 2, and widen out the distance between 2 and 3, it's going to look like there's maybe a spike between 1 and 2 that is different than the spike between 2 and 3. Does that make sense? Okay. It'll look like things increase much faster than maybe what they decrease, and that's something we want to pay attention to and make sure that we don't mislead our audience. So pretty easy. These are just basically ordered pairs then. So 0, 7, plot that point. I'm going to use X's. When I draw a circle and shade it in, it's thinking I'm doing like, oh, there, it didn't do it. Stupid. Sometimes it brings up that window for me to do something else. So I'm going to go 110. I'm going to go, 214. See? And then I'm going to go 39. Okay. And right now, it's basically a scatter plot, right? Okay. Which is not the graph we want. We want a line graph. So we're going to take our line tool, and we're going to connect them. Okay. So it looks like somewhat of a, from 1 to 2, there's an increase there. From 2 to 3, there's a decrease, right? But the slopes of those just look like they're almost the same, correct? One being positive, one being negative. But like I said, if we were to have squeezed this 2 in here to like right there, and then pulled the 3 out a little bit, the rate of increase still would have been based off the data, would have been pretty close to being the same as this rate of decrease. But graphically, does it look like this increase was much faster or much greater? than what this decrease was. Does that make sense, everybody? So that's why we want to make sure that we keep our intervals consistent. Okay. Anybody have questions on constructing a line graph? Kind of something you've been doing since maybe like third grade, right? Not that hard. All right. Bar graphs, another thing that is not new to you. Okay. Bar graphs, not always, but predominantly are qualitative. Okay, so it's usually using categorical data, which is usually nominal. Okay, so you see here we've got a scenario of, I don't know, did I put the scenario, says the horizontal axis? No, it talks about heating, cooling, water heating, appliances, lighting, electronics, and others. So maybe this is like energy consumption for maybe a home, okay? And it breaks it down into the types of systems that consume the energy, okay? If you notice, obviously the bottom is our categories. The y-axis will be your frequency, okay? And now here we're seeing our frequency being referred to as percentages, so it's our relative frequency here. Does that make sense, everybody? But a bar graph, like I said, you always want to create with rectangular bars. It can be vertical or it can be horizontal. Here we've got a vertical one. Says the bars must be of consistent width. Okay. If I vary the width of the bars, it will let one category to the audience look like it's more important and holds a greater weight than maybe another bar. Does that make sense? Okay. So we don't want anything that will kind of play tricks on our eyes and then obviously play tricks on our minds. Sometimes one thing, here they're all varying colors, but something that a lot of times you'll see in articles written or publications is all your bars will be like blue and then one of them will be red. What are they trying to do? What's an author trying to do if they make them all blue but one of them red? Say it again? Yeah, they want you to focus your attention on the red category and persuade you in a way of thinking. Okay, so keep those things in mind. Okay, usually if you see the ones like if you were to use like Excel to create a bar graph for us, we would see that it's all going to produce every bar is going to be the same color for that reason. Okay, you can go in and switch them, change them, but initially by default that's the reason. Bars can be, like I said, horizontal or vertical. Probably 95% of the graphs you see are vertical. Bars are of uniform width, and they're spaced. Okay. If I zoom in here, there is a little space between each of these, but they are not continuous. Okay, we'll talk about that with histograms. Histograms have a different structure than this bar graph. So the lengths of the bars represent the frequency or relative frequency for each category. And it's and this should be all graphs. It's well annotated. You've got descriptions on your x-axis. You've got descriptions on your y-axis. Now, I know I don't have the specific descriptions on this one, but we do have the percents, which is essentially standing in for my y-axis, right? Okay. You carry these over 29 there. You carry this over 17, 14, and so forth. So we've got a situation here. It says Park City is broken down into 6 voting districts. So the table shows the percent of the total registered voter population that lives in the district, as well as the percent total of the entire population of each district. Okay. Now, they like to do this. They like to give you more data than what you need to construct a graph. Okay. Here it says construct a bar graph that shows registered voter population by district. Well, that right there tells you what 2 categories to use. Registered voter population by district. Does that make sense? So that last column, extra information that we don't need. Okay, and that's one thing that in like homework problems, test, quiz questions like that, They put that in there to be a distractor to you. Okay. What type of data is this information here? Districts are like District 1. Is that like is District 1, is that more important than District 2, or is it twice as great as District 2, or twice or half as good as District 2 or something like that? Or is District 2 just like saying one area over in District 2 is a second area or region, right? District 1 is a name, isn't it? Does that make sense? Even though we're using numbers, it's like saying 45801. That's a zip code, right? But it's a name for a particular region, okay? 45820, range for another region, or a value for another region, okay? So they're names. So nominal data, does that make sense? Okay. Categorical, we're going to have our x-axis play the role of our districts. So what I'm going to do on my x-axis, I'm going to put 1, 2, put my names down here, put my categories. Now, do I need to put them like that? Do I need to put them in order like that? Does 1, like we said, does it matter that 1 comes before 2 or 2 comes before 3? No, it's because they're district names, right? Okay. So if you want to put 2 first and then 5 second and then 3 and then 6 and then 4, you can. Okay. And maybe we'll talk about that here in a little bit and seeing what that visual would look like. The next thing we're going to do is look at our population of registered voters and their percent. The highest percent is 22.8%. So I'm going to make my y-axis, just for convenience sake, go up to like 25. Okay, so let's just go. We'll go 5%, 10%, 15, 20, and then 25. Okay, so this would be, we would write down here district, and then over here, I run out of room, but you would say registered voter population. And now we're going to fill in this with bars. So the reason I put these hash marks here, these hash marks are going to be essentially the midpoint of the bars that I use. Okay, so we're going to say, I'm going to take this bar here, and District 1 has 15.5%. So I'm going to do that. Now I got to kind of guesstimate, right? Because I just got 15 going by 5s here. So usually what you do is on the top of that bar, then you write the actual exact value that we're looking at. So 15.5. You can do it like they did here. They type it in the top of the bar. I like to set it on top like this. Is it okay? Can we do that? Pretty easy? Okay. So now District 2 was 12.2%. 12.2. 12.5 would be about right there. So I'm going to bring it down a little bit, and we've got 12.2. District 3, 9.8. Bring that down. District 4, 17.4. About halfway in between 15 and 20. My scale is getting a little bit. Notice I want to keep, I want to keep this gap that is consistent between each one of these bars. I want to keep that as close to being equal as possible as we're making our graphs. 5 is 22.8. And 6 would be 16.8. Oh, no, I'm sorry. 22.3. I was reading the wrong column. 22.3. Is everybody okay with creating a bar graph like that? Pretty straightforward. Now, your bar graph, if I just said, here's your data, you create a bar graph, you could have created that, okay? Your neighbor could have been a little bit different, and your neighbor's y-axis could have gone by ones, right? Okay, or they could have gone from 0 to 100, so then all of their bars would have been compressed and a little bit shorter than yours. You could have, like your neighbor could have put District 6 first. So let's say this. What district up there is the greatest? 5? So let's say your neighbor put 5 first, and then they put 6, and then they put 4, and then they put 1, they put 2, and they put 3. And if they did that, they would have put them in descending order from largest to smallest, right? Okay. And that could then maybe show a pattern. We call that a Pareto chart. Okay, when they do that. Now there's more to a Pareto chart than just that. But if it's a bar graph essentially that is put in regards to the size of its bars from from greatest to smallest. Okay. And we can do that because those numbers on the bottom, 1, 2, 3, 4, 5, 6, like I said, they don't matter. They're names. Okay. They're categories. So you can jockey those around as you see fit. Your neighbor may have done something like this. They could have taken take the information and they could have put District 1 here, District 2 there, 3, 4, 5, and 6, and now they could have gone down here 5%, 10%, 15%. So then, if I'm going 15, that District 1 was 15.5, so they could have gone something like that. Second district was 12.2, so it could have looked something like that. District 3, 9.8, something like that. Does that kind of make sense? Okay, so that's a horizontal bar graph. Okay, you'll see those every once in a while. A lot of the like COVID-19 data that you would see, maybe them comparing different countries and their infection rates and stuff like that. A lot of those end up being, for whatever reason, horizontal. Okay, but most of the time bar graphs are vertical, but nothing wrong with them being horizontal. Does anybody have questions on this stuff? Pretty straightforward. Okay. Now here's my